Welcome to our webinar today on how to successfully install and commission NB-IoT and LTE-M modules, ensuring time to revenue with IoT field testing, sponsored by Keysight's Nemo wireless network solution. Today we'll have a look at how to ensure coverage and service quality of IoT applications. Our presenter today is Deepak Sivakumar, Solution Marketing Manager at Keysight Nemo Wireless Network Solution. As a note, if you have any questions, please ask them at any time. We will share with you both the recording of this webinar today, as well as the slides afterwards, so look out for that. Thanks again for joining. Take it away, Deepak.
Okay, thanks a lot, Ben. Hi, everyone. Morning, good afternoon to everyone. I'm Deepak Sivakumar, part of the Nemo Wireless Group within Keysight, mainly focused on both 5G and IoT testing. Very nice to have all of you on the call today. Today's agenda mainly focused on IoT performance. So we have done webinars in the past, very recently 4 webinars this year, really talking about the technology that has been deployed. And at this point, there are commercial networks out there with NB-IoT and Cat-M1, and we wanted to talk a lot more about optimizing those networks at this point. So, a lot of the networks have moved past the initial concept into actual deployments, and we wanted to get into those details as well. We will definitely talk about our solutions as well on how we are helping our customers out there in the market today, mainly for both NB-IoT and Cat-M1 testing, and also share some of the use cases that we are seeing on the field today. We will have questions and answers as well, so definitely send us your questions, and I'll definitely be monitoring the chat window as well. All right, so our focus today is mainly about the about wireless IoT, cellular IoT, or mobile IoT. So this is where you will have both complementary and competing technologies, and by no means is this an exhaustive list what I have out here. But this should at least give you some sense on what technologies are available in the market today in terms of IoT. So you have technologies that are 802.11, 802.15 focused. That's what you see on the left side: Zigbee, Wi-Fi, Bluetooth, RFOC. And then you have on the right side, low power, wide area technologies such as LoRa, Sigfox, and 3GPP specific technologies as well. And low power wide area because the devices, the solutions utilize really low power, and hence the word low power wide area. And our focus today is mainly on 3GPP specific technologies. So that is mainly narrowband IoT, NB-IoT, and Cat-M as well, or LTE mobile. Okay. And there are differences traditionally with 3GPP. It is going to be a very standardized approach. There will be inter-vendor operability, and there is a lot of testing that is happening as well. With LoRa and Sigfox, what you see up here, those are proprietary. That is more of a proprietary approach, and there is another ecosystem that is revolving around LoRa and Sigfox. But our focus today is on the red dotted circle that you see there, that is 3GPP specific. So a little bit about Keysight. So Keysight is formerly Agilent Technologies, as most of you already know. And we are the Nemo Wireless Group within Keysight, and mainly focused right now on both the IoT testing and 5G testing as well. So we are purely products-based business, and what you see here is both we have different layers here. There is the collection layer that you see on top. There is the control and monitoring, which are tools that you would actually use to control all the devices on the field. So if it is IoT testing that you are interested in, then there are devices that will be on field in either remote locations, or you will have engineers walk around with collection gear. And finally, the bottom layer is the post-processing, which gives you the analytics that comes out of all the collection, out of all the collected data on the field. So, so different layers, and we traditionally started off with in the 2G days, and right now we have arrived at 5G, and especially IoT testing. And the IoT testing that I will talk about today is mainly LTE IoT, But there are plans with 3GPP. There is a seamless migration plan when 5G NR comes up. There will be this existing LTE IoT investments that operators have made will roll into 5G or will seamlessly work with 5G NR at that point. So a lot to talk about today. And specifically, just wanted to clarify on what we measure and how we help our customers today. So what we measure is the air interface between the eNode B and the UE. So the UEs are the terminals. So this can be this can be the devices. This can be the phones, or this can be an IoT module or a scanner. And we measure the air interface between the device, the terminals, and the eNode B at that point. And in the future, it would be the GNode B at that point. Okay. So we measure the radio access, the air interface at the radio access network. And in terms of technologies, there are, and our focus today is NB-IoT and LTE-M or Cat-M1. And there are a lot of, investments, heavy investments by the operators. There are also a lot of deployments that are happening. A lot of the operators have started really with LTE-M just because it just serves more use cases. But we are seeing this trend where the operator would have an existing Cat-M1 deployment, but they would also start testing NB-IoT as well. So very important to understand both the technologies and the testing that comes with both the technologies, because primarily there is a difference between both as well. Each one of them have their own use cases and certain segments that they actually service in terms of who their end customers are. So for instance, just to talk a little bit about both LTE-M and NB-IoT, a lot of the times there are questions on what is the primary difference, with Cat-M1 or LTE-M, the bandwidth, you have higher bandwidth, right? So you have around 1.8 megahertz of bandwidth, whereas with NB-IoT, you have lower bandwidth, it's around 180 kilohertz. So the deployments also with NB-IoT is mainly half duplex, whereas with Cat-M1, you would see full duplex, you can see full duplex investments. And in terms of capacity with LTE-M, the throughputs or the data rate can go as high as 1 megabit per second, whereas with NB-IoT, the actual data rate is a lot smaller. That's why you see it lesser in here. So it comes up to a 250 kilobits per second in terms of NB-IoT, and also the types of deployment that you would see is much more though. There are more deployment techniques. So NB-IoT can be deployed, in the guard band, or you could have, non-traditional operators come by and deploy it in as a standalone NB-IoT system. There are also intra-band LTE deployments as well. With LTE-M, it is mainly in-band deployment, whereas with NB-IoT, it can be in-band or guard band, or it can be a standalone deployment as well. And there are other, in terms of the actual use cases, NB-IoT is more focused on, massive IoT specific use cases such as smart metering, logistics, and mainly asset tracking. Whereas with LTE-M, it is more of the critical IoT use cases such as, you have your connected cars, there is healthcare, there are critical IoT use cases, there is remote surgery, remote training. So we will start seeing different verticals start utilizing LTE-M technologies as well. And primarily in terms of the coverage, there is a difference in coverage as well. With LTE-M, there is 15 dB more coverage than the traditional LTE, whereas with NB-IoT, you would see almost 23 dB. You would see a 23 dB boost over LTE. And that's why there's more coverage use cases, especially you would start seeing with NB-IoT use cases where, it might be in a garage or in just really remote locations where it is otherwise hard to get a person to go out in order to either collect a meter reading or to fix an issue. So in those cases, NB-IoT is more, NB-IoT is a more feasible solution in those use cases. And in terms of density, we will start seeing, you know, a lot of these devices out there. So in terms of density, this is, you know, this slide mainly talks about, you know, just different, you know, features that come with NB-IoT. Really high density, so tens of thousands of devices per cell. And these devices, though, would be communicating very, you know, the frequency of the communication would be very less compared to what these LTE devices out there today, you know, how often they communicate with the base station. So what that allows us to do is, you know, have more devices latched onto a specific cell. And these devices have the ability to go into deep sleep as well. So those are the power save modes that we will talk about as well today. Extremely low cost for the devices as well. The modules are, you know, it's meant to go lower than $5 per module. The development boards, though, that are available today are more expensive since it is mostly in the testing phases. But once these modules are available, once these form factors are released, we would see really low-cost modules released at that point. Battery life, we will start seeing devices that go up to 10 years in battery life. So what that means is, you know, some of these devices would just go into deep sleep. And that's where some of the testing that happens would have to be specific to power save modes as well, especially with NB-IoT and Cat-M1. There are the DRX modes, which is the discontinuous reception. And we'll talk a little bit about that as well. And then extreme coverage, you will have higher coverage, you know, anywhere between a boost of 15 dB up to 23 dB compared to existing LTE. And then when it comes to upgrades, the network equipment manufacturers have made it very straightforward. Well, it is still complex when it comes to making the upgrade, but at least in terms of investments, you know, in existing LTE networks, the folks can actually, the operators can actually upgrade their existing RAN infrastructure to support NB-IoT and Cat-M1. And that's something that is already happening in the market, is happening across multiple countries. And that's what we support as well today. So here are some factors that impact NB-IoT, Cat-M performance on the field. Mainly, and there are a lot of them, but these are some of them that we have documented. So there are network configuration specific impacts. There are radio conditions. If there are chipsets that are already used, those get impact. And especially when it comes to the IoT modules baseband on the front end, those can also impact the NB-IoT or Cat-M performance. And you know, the payload size as well. You know, we spoke about the data rate a few minutes ago. With NB-IoT, it's up to 250 kilobits per second, whereas with LTE-M or Cat-M1, it is going to be as high as 1 megabits per second. So the payload size is also going to impact the performance. And really the, you know, interoperability between all the devices are very crucial as well. So there are different test cases and different use cases that we support today, and really the test scenarios that we see happening in the market as well. So here are a list of IoT test scenarios that are happening across the industry, mainly starting with early lab and field testing. So this is where you actually have modules, IoT chipsets or IoT modules or development boards from vendors, which you would then test on your network. So if you are an operator or if you're a services company working with an operator, at that point, there is a lot of early lab and field testing where you're actually testing out all the key radio metrics. You're looking at your signaling information to see if all your, you know, all your attaches and all your RRC information is being captured. So you're really looking at the radio stack at that point to see all your, you know, your early lab field testing KPIs. And then, you know, along with that, the other things you're measuring is your coverage KPI. So at this point, you would start looking at your RSRP, RSRQ, you know, SINR, all your, you know, coverage specific KPIs. And then going into power consumption is where you start playing around with your power save modes. There are different timers that come with, you know, the 3GPP's NB-IoT, mainly in terms of the T3412 and the T3324 timers. So these are timers that you would otherwise have to play around with to see what is best, especially when you want the devices to go to sleep. You also want to monitor that it does wake up after your, you know, your timer expires. And once it wakes up, it has to do that timing area update at that point. So those parameters, KPIs, have to be tested as well. When it comes to device benchmarking, a lot of different types of benchmarking that is being done. One is a pure benchmarking across different modules or chipsets when you actually test it out on the operator's network. So if you wanted to test out IoT device A, device 1 versus IoT device 2, you do have the ability to actually, and then that is something that you would have to do to see how each one of the devices perform, especially during your certification. When you do a lot of your device certification internally within your company, within your operator premise, you would have to see how one device performs versus the other, and if it meets all your standards before you actually certify that device on your network. So there is device certification, but eventually, at some point, once these networks mature, you would start seeing operator benchmarking as well. Especially if you're a building owner or if you're a neutral host vendor, company. At that point, you might want to see how is who is the best operator with the IoT performance in your venue. So if you're a casino or you own a building or a stadium, at that point you might want to see which is the best IoT network in your venue. Is it any one of the operators? So that's where the operator benchmarking also starts happening. Sorry, actually that's the network benchmarking I'm actually talking about. And what we will start seeing a lot at this point is network acceptance. So as and when the network operators start rolling out their networks, whether CAT-M or NB-IoT, there is a need for network acceptance, especially to sign off on these different base stations to just a pass red light, green light that tells you if you get all your KPIs. If you have the right number of repetitions, if you have your accessibility, retainability, mobility KPIs. So that's mainly your network acceptance specific KPIs. And you will start seeing a lot of different testing when it comes to acceptance. There is the stationary test. There are mobility tests as well with CAT-M, especially with CAT-M. There is going to be VoLTE. VoLTE is going to be supported on CAT-M. And with VoLTE comes connected mode mobility as well, CMM. So you will see a lot of test cases evolve, and as the operator starts releasing these different specs and different releases, these would have to be tested on the field at that point. Okay. So I covered network benchmarking already. So SLA verification is when you actually, So this is where the operators have now opened up the network to multiple verticals, and their end customers start latching on to the NB-IoT network. So there are verifications, SLA, service level agreements, and verifications that happen on the field. That it's mainly to make sure that the right amount of coverage is seen at different locations, especially when you do an NB-IoT field test. And finally, the most important thing that from what we see today is the actual troubleshooting of these IoT networks that are deployed on the field, mainly because on the air interface, there are issues that you would start seeing, especially with lower coverage areas. You would start seeing a higher number of repetitions. And as you start seeing a higher number of repetitions, you start seeing coverage enhancement levels go up as well. So all of that testing is very important on the field. And with that, very important to also see your layer 3 and your RRC signaling so that you can actually track all your RRC connection attempts, or your attempts and your failures. Very important to understand all of that on the field. And the last one is the actual repetitions or your subcarrier spacing, your RACH metrics that you actually see on the field. And especially with RACH, very important to understand your RACH access delay, because if your IoT device or your module were to detach from the network and attach back onto the network, it's very important to see how quickly you latch back onto the network. That initial RACH access procedure, is one of the more important KPIs that we see a lot of operators utilize today. Finally, in terms of analysis, there is the ability to, and very important to also look at how your KPIs that you collect on the field look like, especially when you run analytics to understand which areas are locations that you have to go back and fix. when you do your troubleshooting at the end of it. So in terms of signals and service coverage verification, a lot of the KPIs, a lot of the testing, that you would see happening is mainly, you do have field testing, outdoor testing, but you would also start seeing a lot of in-building testing as well for NB-IoT and CAT-M. So at that point, it's very important to understand your coverage enhancement levels. So that's where you have, different coverage. With NB-IoT, you have CE levels, but with CAT-M1, you have CE modes, coverage enhancement modes. So you will start seeing your repetitions, your RACH delay, your SINARs, RSRQ, which is your quality specific KPIs. And there are different tests that you can actually perform on the field. You can definitely do stationary tests, but you do have the ability to actually do active testing. So you can actually simulate a lot of the user experience related tests. So if you wanted to download if you wanted to download a small file, an HTTP file, you could download a file, or you could actually do a data transfer, a TCP UDP transfer. And one of the more important KPI, one of the more important tests that we see happening is the ping test. So you could do you could send 1,000 pings to see what your round trip time and your latency looks like. And at the end of it, there is also the power saving settings. So this is where you have your discontinuous reception or your DRX. And with eDRX, your device goes into deep sleep, and it has a longer wake up time at that point. So you do have these timers as well that you can set, that you can tweak when you do a lot of this testing when you're in the labs, or even if you're on the field at that point. So we have, really, the solutions that we have come up. We do have a laptop flavor, and we also have the handheld flavor as well. The laptop flavor, as you're looking at, allows you to connect up to 8 devices, to the laptop. So you can have 8 different modules or IoT modules connected to the laptop, and you can do any of those tests that I mentioned earlier. In terms of lab testing or field testing or network benchmarking or device benchmarking. You can also add on a scanner as well to the laptop in order to do a scan of your NB-IoT frequency to really check to see if your NB-IoT to see if your scanner RSRP is the same as your device RSRP. So there is scanner-based testing as well that we do support. That is when it comes to the laptop-based collection. We do have smaller form factors as well. We have the phone form factor where you can actually connect the dongle that I'm pointing to, so one of these dongles, to the phone, and pretty much walk around and do a very easy test to see how your IoT performance is in your venue. Or it can be a venue, or it can also be a drive test. So you could take the same dongle, plug it into one of these phones that I'm pointing, and do a drive test as well, and collect the same level of KPIs and information. So different form factors, mainly when it comes to your specific use case, we have to see which is the best fit. But we'll now get into the different use cases as well on the fields. But really, we support all major bands, so up to 15 frequency bands. Also, all the major operator bands are supported. And all the tests that we mentioned in terms of HTTP, pings, all of them are supported as well. So here are some use cases and who our user segment is, who is actually using these solutions today in the market. So the first layer here is IoT Handy and Nemo Outdoor. So this is where you would actually see network operators or service providers or network equipment manufacturers who actually work with the mobile operators test. So this is where you would see your detailed layer 3 messages. You have a decode of all your messaging. And really, you're collecting all your KPIs at that point. And once you collect all of this information, you do have the ability to process all that data in our post-processing suite, which is Nemo Windcatcher, Nemo Analyze, and there is also Nemo Synergy, which is the enterprise tool as well. So across these 3 tools, you can process all the data collected on the field and run analytics really to see if it is a network site acceptance use case, right? Or if it was a cluster acceptance, and say you have 200 to 300 sites or more, how many ever sites, you could actually collect all of this data, plug it into a post-processing, and we would crunch and give you reports that tells you whether it is a pass or a fail. The last product that you see here is the IoT meter. So the users for IoT meter is a little different from our traditional users. So the IoT meter users are mainly the non-technical folks. So it might be a power meter company, or it could also be a technical person. But really, the use case is to very quickly see what your IoT coverage is in a specific location, and you can do a drive test or a walk test in this case as well. But it just gives you, at the end of it, it just gives you high-level KPIs to tell you what is the best location to install my IoT device. So that's the one I just spoke about, the IoT meter. So you can see that it's a very easy to use handheld tool. You can walk around or drive around with this tool connected to a modem. So it's really a S9. It can be an S9, a Samsung S9 or a Samsung S8, connected to a dongle, which would then collect actual measurements across the air interface and tell you what does that IoT coverage look like. So in this case, you can see the IoT coverage is around neg 106. RSRQ, I have some RACH. If you were to see the RACH axis delay, that would be calculated as well. But it gives you, at the end of it, it tells you what my round trip time is. In this case, it is around 6 seconds, which is not too good. That's why I have 1 star. But it tells me right away on the field, just basic KPIs when I do a field test. So really, the locations where the IoT devices are used, is really basements, cellars, underground locations where it is otherwise hard to walk around with a laptop. In those cases, the phone can be used with an IoT modem, which we provide as well, which collects all the key KPIs in terms of understanding if it is a good location to set up an IoT device or not. But at the end of it, you can very quickly create a report on device itself. So you really don't have to go back to your office to understand if your IoT coverage is good or not. But instead, you get to see on field if it is a good location or not. So here's the process. You set up the details. You geolocate yourself on the map. You start test. You do have the ability to add a picture as well. So there is an add photo option where you can take a picture of the IoT device that you're testing or the actual location that you're walking. But at the end of it, you get some key KPIs, which you can then finish testing and create a quick report as well. So that was the IoT meter that we spoke about, very targeted for the verticals or the network operators and customers. There is also the IoT solution, which is the more robust solution, which provides you all your key KPIs in terms of field testing. So this is where you would actually start seeing all your layer 3 messaging. And you can see in this snapshot, we show you all the band information. We tell you if it's on NB-IoT or CAT-M or LTE-M. And also you start seeing your serving RSRP, RSRQ, SINR, your repetitions. So really all your IoT parameters are captured in this case. And the way we do it is by utilizing one of the existing, the application is actually on a commercial phone. So the one you're looking at is an S9. So once our application is flashed on the phone, you're able to run this application. And here's a quick demo of actually the Nemo IoT platform. So once I initially set up my ping address, once I give it a location to ping, and how many times do I want it to ping, and how often do I want it to ping? In this case, 1 second. At that point, I can give it the access point name as well, and I can start the test. So you can see the red dot here means the test is started, and I can actually see my RSRP or my NRSRP, which is my NB-IoT RSRP signal. If it is CAT-M, I would see the same thing as well. I would see my CAT-M signal as well. But you do see more details. You do see preamble repetitions, which is 8. My coverage enhancement level is 0 at this point. But if that preamble repetitions were to increase, you would see an increase in the coverage enhancement level 0 to 2. In this case, I have my ping round trip time. there are 4 pings that have been done, and I have my round trip time that is shown as well. I also have my min-max average round trip time as well. And if I were to see any failures, that would be reported as well. Along with that, here's a summary of all my my band and what band I'm on, frequency I'm on. I can also go through my layer 3 messages and click on any of my messages to see if I wanted to track any of my, my layer 3 activities. So if I wanted to see my timer information, or if there was an attached attempt, all of that can be tracked in the layer 3 messaging. Besides that, this also tells you if it is an in-band PCI, what are the repetitions, how many repetitions are happening across my RF interface, and once I do my field test, I can always walk into a building and do a walk test. So I can take a picture of the floor plan in my building and start doing a walk test. So I'm actually walking at this point, dropping markers to see really how my IoT performance is within a building. So imagine this to be a basement or an underground situation where you really have very poor coverage. So at that point, you can measure your IoT performance in a building as well. Some of the other things that you would see is your SINAR, and there is also your round trip time. And at the end of it, once your collection is done, once you're done with your in-building test, and you can have multiple floors, right? You can have up to, you can have multiple floors that you can switch across, do multiple walks. But at the end of it, you can always create a report that you can then email out to your end customer, or email back to your, HQ to analyze the data. So very comprehensive in terms of what we collect on the field. So here's a snapshot of our outdoor solution. So we went over what our handheld solution so far, but here is our outdoor solution where you can connect up to 9 devices, including a scanner. So you can have 8 devices plus a scanner, and you can also have not only your NB-IoT devices or your CATM devices, but you can also have legacy devices as well. So if you wanted to test your NB-IoT performance versus your LTE performance, you can also have an LTE phone connected to the laptop and do a drive to see what that performance looks like. Really a benchmarking between the existing LTE performance and your NB-IoT performance. And going into 5G, we do support scanners as well, 5G scanners as well, which can be connected to the laptop solution. And once the terminals are available, you would start seeing these terminals that are plugged into the laptop solution as well. So we do support all the major frequency bands, and here's a list of frequency bands up, back here. So definitely talk to us if you have any questions on the frequency bands, and if we do support your specific band and channel. And in terms of the actual devices, we do support both form factors. There is the dongles that are supported. There are also mini boards as well. So if it is a development board such as the SIMCOM or a U-Block SARA, there is also Quectel. There is the BC95 or the BG96. So some of them would be you would start seeing some of them are based on the Quectel. Some of them are based on the Qualcomm MDM9206 chipset. There are also new or the Huawei chipset variants. So we do support both of them as well for field testing. Okay, get to the next slide here. All right, so here's some views from the outdoor solution. So what you're looking at is some active testing where we are actually running pings. We are running pings, and we are also doing a data. We are also doing some downloads. So in this case, you can see a live demo. The round trip time is captured. You would also see all your RSRP, RSRQ, and RSSI. Along with that, my SINAR is also captured. So all of this is being done real time, and you can have up to 8 devices connected. But you would also start seeing all your physical layer, KPIs like your PDSCH, your repetitions, and all of this information is captured, which you can then post-process to actually analyze those KPIs. Your signaling is captured as well. So if you wanted to look at any of your RRC information, all of that can be looked at as well. So here's something with RACH, your RACH information. So if you wanted to look at your RACH preamble count, what is your RACH path loss, or what is your RACH access delay, and if your RACH actually succeeded, all of that is also captured. When it comes to post-processing, one of the things that we have seen on field is that there is a large amount of data that comes with IoT field testing as well, especially if you were to do extremely large drives, if you were to do market-wide drives, especially for acceptance, and if there were multiple devices as well. So if you had multiple IoT chipsets, each one connected to a different band, because you do have the ability to lock these devices to different bands as well. So if you were to lock these devices on different bands, and if you were to do a drive test, at the end of it, it's very important to actually really post-process and analyze this data. And in order to do that, we do have post-processing platforms as well, Windcatcher, Analyze, and Synergy, which post-processes all of this data. So that's what I'm showing you right now. All your RF metrics, your NB-IoT metrics, and all your RACH metrics all captured, along with actual drives. And really, there is no need for you to actually do this manually. The post-processing tools are intelligent enough to automatically create these reports for you very rapidly, so that you really don't have to wait, to submit these reports back to your higher management or your senior management. And in terms of actually post-processing, here's a quick walk of a in-building scenario, in-building venue. At the end of the actual walk, in this case, the test is to actually verify if I have good coverage and what is the right location to actually install an IoT device or an IoT meter. It can be a power meter or a water meter, whatever the IoT device is. In this case, you can see that after the walk is done, the green shows really good coverage and good transmit powers, whereas what you see in black and red are locations where there are a high number of repetitions, and with each repetition, it consumes a lot of power as well, something on the lines of 3 dB at that point. And if there are a high number of repetitions, the device will consume a high amount of power as well. And the objective is to have these devices installed, and they are supposed to function. They're supposed to go as high as 10 years without batteries. But if you were to install it in a location that has poor coverage, these devices they will eventually run out of power very rapidly. So in this case, the best location to go and install these IoT devices would be places where shown in green. Okay. And also there are other tests, mainly when it comes to coverage edge testing. In this case, you can see that this is mainly for quality of service verification. As the RSRP starts dropping, as the RSRP starts dropping from neg 80 to neg 121, we have bad SINAR as well. The ping latency, the round trip time spikes up from really low up to 25 seconds. And at that same time, we also start seeing a lot of repetitions as well, both on the PDSCH and PUSCH. And on the RACH layer, you would start seeing a lot of RACH access delays. In this case, you can see RACH access delays are up to 4 seconds. And the RACH preamble repetitions spike up as well. They go up to 32 preamble repetitions. And what that means is that when the RACH preamble repetitions were to increase, your coverage enhancement level increases as well at that point. Here is a snapshot of IoT analytics when it comes to benchmarking, and especially when you're looking at two different operators in order to see which is the best operator that you can go with in terms of deploying your IoT service. So if you're a vertical, IoT vertical, a power meter company or a water meter or a parking meter company, at that point, if you're evaluating which operator to actually go with in order to deploy your IoT solution, very important to understand how each operator is performing versus the other. In this case, you could actually walk around or drive test with our solutions and actually see what that IoT performance is across both the operators. In this case, you can see locations where I have yellow is where I have higher round trip time. So higher round trip time means higher latency, slower to connect. So very very important to do this during the field test. So we touched upon coverage enhancement levels when we were talking through repetitions. Really, the coverage enhancement levels are seen in the SIP2, and there are different enhancement levels. With NB-IoT, it's coverage enhancement levels, and you have your normal, robust, and extended coverages. With CAT-M, it's slightly different. You have your coverage enhancement modes. You have your mode A and mode B at that point, with coverage enhancements going from 1 to 4. But what you would see during these coverage enhancement levels is that all your subcarrier, your subcarrier spacing, your PRACH repetitions, and the maximum number of attempts that your module has to perform is captured in that information. And really, this is based on different RSRP thresholds. So as the RSRP were to degrade, right? So if you kept going really, if you started seeing really low RSRP, like say you started seeing neg 130, neg 140, when you started going poorer and poorer, you would start seeing more repetitions based on the coverage enhancement levels that is selected at that point. So here's a snapshot of preamble repetition. So this is during the initial RACH access procedure. So especially if you were to turn off your IoT chipset and turn it back on, and if you were doing a drive test, in this case, you can see that I have a high number of repetitions. I have 32 repetitions I have 32 preamble repetitions, RACH repetitions. And at that point, my CE level in blue is, my CE level is 2 at that point. So that shows a clear correlation between my repetitions and my CE level. And we've been using the word repetitions a lot. So really, repetitions, what that means is that in order to boost the SINR on the receiving end, in order to boost the SINR of the device, what happens is it is a technique where the same transmission is repeated several times, and on the receiver end, it's sort of soft combines, to boost up the SINR level, very similar to TTI bundling, what you would see otherwise in LTE. So in this case, the more number of repetitions that you see, you would start seeing that in lower coverage areas. And here's a snapshot of here's a trend line, a time series chart of repetitions, along with round trip time and serving RSRP. So here's the legend, and I'm looking at red, which is my repetitions. So when my when my serving RSRP were to degrade, okay, and this is a trend line, but I do have a zoomed in plot as well. But when my RSRP were to degrade, when that drops, at that same time, my round trip time in green spikes up, and my repetitions is also higher at that point. And I can actually zoom into that specific location that I just showed to show you that, when I have my low RSRP at that same time, and you can see that there is actually a break in RSRP. So during that time, the one in violet or purple, whatever color, so during that actual break, I have a spike in my round trip time, which is the one in green that I'm pointing to. And at that same time, there is also a higher number of repetitions. I have 1,024 repetitions, which is the maximum number of repetitions that would happen. This is more of a zoomed in view. The previous view that you saw was a trend line. The previous view is a trend line, but what I'm showing you is more of a zoomed in view at this point. Besides that, some other KPIs, some other very important concepts with NB-IoT and CAT-M is your power save modes and your enhanced DRX, or your discontinuous reception. So in release 12 is what we've seen with power save modes. There is the T3324 timer. So that really tells how long the UE has, how much time the UE has to page the eNode B or the the base station before it actually goes into deep sleep, or before it goes into the power save mode or the PSM mode. If the T3324 timer were to be 0, at that point it would immediately drop into power save mode at that point. But once it goes into power save mode, the device, all circuitry is actually switched off. But it's very important to know that there is also a T3412 timer, and when that timer expires, the device would wake up and do the device would actually wake up and do a timing area update. So both of these timers, the good news is that both of these timers can be tested on our Nemo Outdoor platform and can be seen in our post-processing as well. You can actually toggle, you can play around with both these timers on a Nemo Outdoor platform. And you do have the ability to do it through AT commands, but what we have very nicely done is we have added a UI functionality to actually control the chipsets or the modems when actually playing around with these timers. Because very important for the device to actually wake up at the end of the timer expiry to make the timing area update. And when it does the timing area update, that's when you would start seeing all your, all your timer values. So here's the snapshot from our collection platform, where you can either see your timing area. You can either see your timer information in your attach accept or in your timing area update message. In this case, I've used the attach accept, and you can see in here your T3412 timers set to 10 seconds, and you have your T3324 timers as well, along with your eDRX modes as well. Okay, and a lot of the users, especially if you're in the labs, these are timers that you would test. On the field, maybe not as much, but in the labs, it's very important to play around with these timers and see which is best, when you configure it and optimize your IoT network. So that's what we just spoke about, verification of different power save modes with Nemo Outdoor. In this case, once the test is done, once you play around with once you actually configure your IoT, your power save modes, you can always see at the end of it, what is the percentage time your device was connected, when did it drop into idle, and when did it actually go into eDRX, or in some cases like the one here I'm pointing at, it went into an actual deep sleep or the power save mode. Because really these devices, they are not meant to constantly talk to the network. Instead, they have to go into deep sleep, wake up once those timers expire, and then communicate with the network on what it has captured so far. So, and that is really, the use case when it comes to, really remote locations where some of these devices have to stay up and running for up to 10 years. All right. So in summary, with Keysight's Keysight Nemo's IoT solutions, you do have the ability to test your IoT network on the field. You are measuring your RF interface at that point, your air interface, and looking at all your key KPIs that are relevant to IoT, and your application performance KPIs as well. And once all the KPIs are measured, you would actually post-process all of that information in post-processing to actually see all your analytics, to see if your drive or your venue or your actual device is a pass or a fail. And all of these devices, most of these devices, are commercial. A lot of these devices are commercial and available. You can buy them by yourself. And at that point, all you need is our application to actually connect these devices and see, if you can measure the network or not. So, definitely talk to us if any other questions. I'll now open it up to questions, and Ben, over to you.
Yeah, awesome. Thank you so much, Deepak. So I'm going to start with a couple of questions here, but do you support both NB-IoT and Cat-M in your collection, and are those devices commercially available today?
Yes, absolutely. So the question is, do we support both Cat-M and NB-IoT? Yes, we support both, and these devices and our application is commercially available. We do have operators and verticals who actually utilize our solution today in order to measure the IoT performance and also to optimize the IoT performance. The actual IoT modules or the chipsets are also available in the market, so you can either come to us or buy them by yourself and come to us in order to connect it to our application to measure your IoT performance.
Wonderful. Question from the audience, how do you test latency?
To test the latency, one of the tests is to actually run a ping test. With our scripting, what we have available today, you can set up ping tests, and you can actually set up how often you want the pings to run, and you can increase the size of the ping as well. So if it is 32 bytes or 64 bytes or 128 bytes, you can transmit the ping in order to actually calculate that latency or the round trip time, because at the end of it, you do need excellent latency, especially with critical IoT use cases. If you're part of a connected car use case, right? You want to make sure at that point you have excellent latency for V2X use cases, the vehicle to anything use cases.
Yeah, definitely. So another question from the audience, with the app and the smartphone, can you integrate location data with the performance metrics for mapping automatically? Example, GPS outdoors or for other indoors?
Yes. So if you were to walk into a venue, you can actually do two things. One, you can use the existing GPS in order to locate and do a walk test. That is one way to do it. The other option is to use our marker information. So like the venue I'm showing you up here, the second image, the one in between, you can actually drop markers, and then a post-processing solution would actually map that venue information for you along. What it does at the end of the day is it maps the floor plan with the walk route in order to show you where you actually walked.
Wonderful. And then do you offer any similar capabilities for the LoRa or Sigfox standards?
So for LoRa and Sigfox are non-3GPP standards. We don't support LoRa and Sigfox. Our focus is mainly on 3GPP specific technologies, NB-IoT and Cat-M today.
Wonderful. And is this uplink and or is downlink test?
Yeah. So we do have the ability to do both uplink testing and downlink testing as well. So if you were to do a walk test or stationary test, you can set up a script within our platform to do a complete HTTP downlink or an uplink test. You can do both, yes.
Okay, great. For utility companies, it doesn't really make sense overall to invest in heavy test gear. Is there an app that can work with any commercial device or Android off the shelf that can also give you RX, TX levels of IoT cell?
Yeah, that's a good question. So with utility companies, yeah, it really doesn't make sense to walk around with a laptop or any heavy gear. So that's why we have the IoT meter. So in here, there are three devices. The one I'm pointing to at the far left, that's the IoT meter, where you can use a commercial off-the-shelf device. It does have to be flashed with our firmware though, so that you can connect one of our dongles, or the dongles can be really purchased by you. But we actually use commercial off-the-shelf devices in order to do a field test for IoT, because it really doesn't make sense, like you mentioned, to use a laptop for utility companies to measure an IoT performance.
And is there an option to upload AutoCAD floor plans and do a walk test on mobile devices?
So in terms of uploading, AutoCAD images are not supported on our application, but there is one thing you could do. You could do an export of the AutoCAD as a JPEG or a PNG file. Or you could just take a picture of a floor plan if you're at a venue and upload it into our, either the phone or the laptop when you do a walk test. We have heard though that a lot of our measurements that we collect on field can be exported back into AutoCAD though, if that is something that you want to do to measure sort of a pre and post prediction versus what you actually collected on the field.
And I guess which device would be used to capture the data?
S9. So we do work with commercial off-the-shelf devices. The one that I have with me is an S9 device, but you could use an S8 or an S7, Samsung Galaxy S7, S8, S9. We do work with some Sony variants as well. But as long as it's a commercial device and if it can be flashed, then we can definitely put our application on it. So really, at the end of the day, the IoT meter, the one that is mainly targeted for a quick verification, it does not have to be a very big solution. It's a very quick solution that can be flashed with our application on it, and you can connect a modem or an IoT modem to it and start doing a walk test very quickly.
Wonderful. Is it possible to connect the device to some iPerf server?
You can definitely do an iPerf test, yes. So we do have customers who do an iPerf test as well. So if it is TCP or UDP iPerf, there is the ability to do an iPerf test with, along with all the other testing that you do. So, there are customers today that, they, as part of their script, they would first run a ping to start with. They might do a detach from the network in order to calculate what that RACH access delay looks like. And then going into an actual ping test, followed with an HTTP test, and then you could do an iPerf test following that as well. So yeah.
Okay, great. And if you have a higher efficiency antenna, will this improve your reception in a poor reception area?
Yeah. So the devices, like say the phones that that we have today, the dongle in this case. So the phones come with along with the phone. We never use the phone to actually do the collection. Okay, we actually use the modem's antenna. So if you were to switch out the antenna that comes with the modem, the default antenna that comes with the modem, and connect to your own antenna, you could still do a test. If you were to use a higher efficient, a more efficient antenna, you could still get better signal quality at that point.
Okay, great. We have time for a few more questions here. What are some important metrics to monitor during LTE-M collection?
Some of the more important metrics and KPIs to monitor are, your repetitions, because really on the field, the poorer the coverage is, the poorer the coverage area is. When you run into those locations, you would start seeing your repetitions to increase as well, and you want to make sure that that is optimized, especially your PDSCH repetitions. Other KPIs to look at is your RACH preamble repetitions, your RACH access delays, and also your accessibility metrics. So how quickly can you latch back onto the network? So those are some important KPIs. And that's for NB-IoT and Cat-M1. On Cat-M, once Volte is available, once Volte is deployed, you would start seeing a lot of connected mode mobility testing. So that's where you would have your CMM mode turned on the operator's network. So that's where you would have seamless mobility, because with NB-IoT there is no mobility, but with Cat-M you do have mobility when it comes to Volte.
Great. And so in terms of IoT devices or meter, can you latch them to two different service providers and do benchmark tests?
So if that is the objective, with the IoT meter, you can latch on only to one network at a time. You can only latch on to one of the operator's networks. So the SIM card that you pop into your IoT meter, that is the network you would latch on to, whether it is NB-IoT or Cat-M. But if you wanted to benchmark across multiple networks, at that point, the laptop-based solution is the more efficient way, because you can connect up to 8 devices and benchmark up to 8 different networks. So that's the more efficient solution. But you could still walk around with 2 IoT meters, and even from a price point, it is very efficient when it comes to IoT meters. So you could really walk around with 2 IoT meters to capture 2 different networks at that point.
Great. Well, I think that's all the time that we have today. Deepak, I want to thank you so much for today's presentation, and everyone's questions were wonderful. To let you know, we will be following up with everyone with the slides as well as the webinar recording if you wanted to watch it again. Here on this slide, you can see some additional information as well for Deepak's team. Deepak, again, thank you so much for your time today.
All right. Thanks a lot, Ben. Thanks a lot, everyone, for joining the call. We will definitely be in touch. Thank you so much.